Hey there, and welcome. Ever wondered about the math behind chance? You know, how we can put a real number on something uncertain, like a coin flip or whether it's going to rain? Well, that's exactly what we're diving into today. Let's get to it.
So think about it. We say stuff like this all the time, right? It'll probably rain today. It's just how we talk when things aren't a sure bet. And that one little word, probably, that's the key to this whole topic.
Or how about this one? There's a 50-50 chance India will win the match. Or maybe you've thought, I doubt he's going to pass that test. All these phrases, they're all getting at the same thing. We're trying to make sense of an outcome we just don't know yet.
So here's the cool part. Can we actually measure a word like probably with a number? You bet we can. That's where math comes in. It gives us a way to turn that fuzzy feeling of uncertainty into a hard, specific number. So how do we do it? Let's find out.
Okay, here's our game plan. We're going to break it down into 5 quick parts. The world of chance, the language of probability, the all-important formula, then we'll see it in action, and finally, we'll cover the rules of probability.
Okay, first up, the world of chance. This is all about getting a handle on what we mean by uncertainty. You see all these words, probably, doubt, chance, they all have one thing in common, uncertainty. And that's really all probability is. It's the branch of math that lets us deal with things that might happen or might not. All right, moving on to section 2, the language of probability. To really talk about this stuff like a pro, we need to get a few key terms down. Think of this as learning the basic vocabulary. It's super important for everything else. So our first word is experiment. And no, we're not talking about bubbling potions in a lab. In probability, an experiment is just an action. Any action where you don't know the result for sure, but, and this is the crucial part, you do know all the things that could happen.
A perfect example is just tossing a coin. That's an experiment. Why? Because you know the result is either going to be heads or tails. You don't know which one, but you know the complete list of possibilities. Okay, so our next term is trial. This one's easy. A trial is just doing the experiment once, just one time. So if our experiment is tossing a coin, then actually flipping it in the air one time, that's one trial. If you flip it 10 times, you just did 10 trials. Simple as that.
And our last key term is event. An event is simply the outcome or maybe a collection of outcomes that we're actually interested in. So going back to our coin toss experiment, getting a head is an event. And getting a tail, well, that's another event. The event is just what we're looking for, which of course leads us to the big question.
Section 3, the probability formula. This is it. This is the master tool. How do we actually put a number on an event? It all comes down to a really straightforward formula.
Okay, this is what's known as empirical probability. See that P of E? That just means probability of the event. And to find it, it's just a fraction. On the top, you put the number of times your event happened, and on the bottom, you put the total number of trials you did. That's literally all there is to it. All right, time for section 4, probability in action. The formula is great, but let's see how it works in the real world with a solved example. This is exactly the kind of thing you'll run into. So let's say we did an experiment. We tossed a coin 1,000 times. Yep, 1,000 trials. And after all that flipping, here are the results. We got 455 heads and 545 tails. So, here's the question for you. What's the probability of our event getting ahead? Think back to the formula we just saw. How would you set this up? You can even pause for a second and try to figure it out. Ready? Okay, so the probability of getting ahead is the number of heads we got divided by the total number of tosses. So we just plug in the numbers, 455 on top and 1,000 on the bottom. And if you do the math, that comes out to 0.455. Now, wait a minute. You might be thinking, shouldn't it be 0.5, like 50-50? And that's a great point. This is what we call empirical probability. It's based on the actual results from our trials, not just the perfect theoretical idea of a coin. And that brings us to our last part, section 5, the rules of probability. This is all about the boundaries of chance, a really fundamental rule you always have to remember. Here's the golden rule. The probability of anything will always be a number between 0 and 1. Always. You can't have a negative probability, and you can't have one bigger than 1. If the probability is 0, it's an impossible event. You know, like rolling a 7 on a normal die. Can't happen. If the probability is 1, it's a sure event. It's guaranteed to happen, like getting a number less than 7 on that same die. Everything else, every other probability, is somewhere in between those.
Which leaves us with a really interesting thought, doesn't it? If probability is all about using data from the past, how can it possibly help us predict a future that's never exactly the same? Well, that's the puzzle and the power of probability. It's about using what we know to make the best possible guess about what we don't. Thanks for tuning in.